Alright, so regular expressions. That's what we are going to discuss now. So before that, some background about how this regular expression came into picture. We have regular languages. Okay, we have regular languages in TOC. Okay, so these regular languages are all the simple languages for which we can create the DFAs. Okay, like set of string of even length, odd length, starting with A, ending with B. So these are all the what you can say most simplest kind of languages, and these are what I call regular languages. There are ways to identify if a language is regular or not, but let's keep that topic for some another video. But today I'm interested in discussing regular expression. So how does regular expressions fit into all of this? So for any language, not just regular language, but I will talk in terms of regular language here. We have something called as a generator. Something called as a generator. So what is a generator is, it actually generates all the strings of a language. Generator which generates all the strings of a language. Alright, so the generator is what we call as a grammar. In case of regular languages, it will be regular grammar. Regular grammar. And regular grammar can be of two types. First is left linear grammar and another is right linear grammar. And this is not the topic of this not the topic we are going to discuss right now, but I just want to make you get a feel of what we are trying to achieve. So regular languages, we have something called generator, which generates all the strings of a language, and we have something called as an acceptor, which is what we call finite automata. So finite automata, we already know there can be two types of finite automata: with output, okay, with output, and without output, okay, without output. The difference is, of course, for machine to act as an acceptor, it should have final state, and if the finite automata with output, they don't have any final state. So the finite automata without output will actually act as acceptors. So this class will actually act as acceptors, which is actually DFA, NFA, and epsilon NFA. Okay, so these class of machines actually act as acceptors for regular languages, although they all are equivalent in power. So without loss of generality, I can say DFA acts as acceptor of a regular language. Cool. Then we have something I call as a representator. So the regular languages have some special. Not all languages have these representators. Only regular languages have these representators. Now, what are these representators? It's simply a mathematical expression. It's simply a mathematical expression that describes the language. Okay, that describes the language. Now you might ask, why do we need it? Generator wasn't enough. The grammar wasn't enough to actually describe the entire language. It was, but we'll see. This actually makes the analysis very easy. And these representations are what I call regex, or regular expressions. Regex, I write it for short. This regular expression on the basis of many things in the entire computer science. If you remember in computer networks also, in framing topic, in the NIC we actually store the regular expression of the preamble or SFD. If you know that, it's okay. If you don't know, then forget it. But this regular expression is very important thing. We have to. So this regular expression are very important thing. So yeah, let's start the discussion of regular expression. Then I won't bore you. So they are simple mathematical expression. Okay, they actually represent the language in a compact way. Cool. And the language accepted by the language described by this regular expression are referred to as regular languages. I mean, no surprises there. Okay, so let's get used to the terminologies of regular expression. Let's get used to the important terminologies. The terminologies of regular expression. So how can we form this regular expression? So first we have an operators. First we have operator which I call a plus, or sometimes also written as a straight line. It is a union operator. It is a union operator. So these are actually operators, okay. And then there we have this simple dot, which is concatenation, and then we have star. The star is that clean closure or star, whatever. clean closure or star, whatever you want to name it. It's clean closure or star. Okay, and uh, these are the common operators. Okay, these are the operators. These are so-called operators of regular expression because it is an expression, right? What is an expression? Okay, yeah, that's important. I hope you know what is an expression. What is an expression? It is actually operands combined together, operands combined together by means of operators. Okay, I guess yeah, by means of operand operators. So okay, it's a collection of operands combined together by means of operators. That's what an expression is. So I call it regular expression because it represents all the it represents regular language. So these are the operators in regular expression, and let's see some what I call primitive regular expression. Primitive in the sense most basic kind of regular expressions that you can form using these operators. Okay, first is phi. Now, what does this phi represent is? This phi implies the language it describes is actually empty language. Okay, because they help us describe the languages. So, I'm discussing the most primitive regular expression and what languages do they describe. Then we have epsilon, or you write it like this, or lambda, whatever. It represents the language which contains the empty string epsilon. Okay, or this epsilon or lambda, whatever. Then we have, let's say we have a alphabet A B, and if I simply write A, it implies it represents the language containing the single string A. And if I simply write B, it represents the single language containing the language containing the string B. Okay, cool. And we have a point 2. Okay, some complex regular expressions. Okay, there is no name like complex regular expression, but I just named it. Let's say R1, R2, R3, R1, R2, let's just say R1, R2 only. R1, R2 are primitive regular expressions. Then R1 plus R2, that is R1 union R2, R1 dot R2, that is R1 into R2, and R1 star or R2 star, whatever, are also regular expression. Okay. Examples for it. Let's see. If I write A plus B, it actually represents set of languages which contains the string either A or B. So it is actually A or B. This is the language it represents. If I write A dot B, so or a concatenation B. Sometimes we omit this dot also for simplicity's sake. A dot B, so I can simply write it like AB also. It represents the language which contains a set of strings, then which A is followed by B. Okay, so what does this do is, I mean, when I write this concatenation, what does it mean is, if I write A plus B, and if these regular expressions represent some language L1 and these represent some language L2, the language represented by A plus B will be L1 union L2. Okay, and in case of A dot B, if it's the same the case, the language represented will be L1 dot L2. And the dot here is you take the Cartesian product. Okay, so Cartesian product, I mean the order matters. Cool. So in this case, it was actually dot A into A into B. So the answer will be AB, right? Simple. Cool. So that's that. And yeah, one more thing I forgot to mention: A star. So what is A star? It's actually empty language unions. Simply A union A 2 times. Okay. Union or rather say A dot A union, or I'll write A and so on and so forth. So basically in place of the star you can put anything, 0, 1, 2, so on and so forth. So that's what it is. It's actually what I can say, you can write it like a set of all strings over the alphabet which contains only set of all string alphabet contains the only symbol A. So it's actually epsilon A, so on and so forth. I can extend this idea to this. If I write A plus B star, what does it mean? A plus B star. What does it mean? A plus B star. It is actually like this. It's either epsilon. If in place of star, I can actually substitute anything. It can be 0. If I put 0, it will be epsilon. If I put 1, it will be epsilon. Let's write it like this way. It's epsilon union A or B union. If I put 2 here, it will be AA, AB, BA, BB, and union, and so on and so forth. So basically, it is a set of all strings, set of all strings, the set of all strings over AB, right? Over the alphabet AB. That's what it is. So I guess I forgot to mention one more point. We can actually apply, I mean, these are what I can say a complex regular expression or complex regular expression, and you can actually take this R1 and R2 and you can apply these operations, these operators any number of times and you will still get a regular expression. That is R1 into R2 is a regular expression, and I can take a star, that's also a regular expression. R1 plus R2 into some R3 is also regular expression. So basically you can take this complex regular expression and apply the operators that we have discussed till now as many times as possible, and it will still be a regular expression. But there's a problem here. What's the problem is, what if I give you a regular expression A plus B into C? How do you interpret it? Do you interpret it as A plus B into C or A plus B into C? These two languages are different, okay? This language will be actually equal to AC and BC, right? Either A followed by C or B followed by C. And this language is actually either A or BC. I mean, they both are completely different languages. So, I mean, that's what. So, this is a confusion, right? How do I associate these operators? So, that's where precedence rules comes into play. The precedence rules are like this. As we go from here, the precedence increases. Okay, the precedence precedence decreases. So star has the highest priority. Then dot, and dot is greater than plus. Okay, so this is the precedence. That's what I mean. This is the precedence. So in this case, dot will be given high priority. So it is actually equal to this part. Okay, so it represents this language. Okay, so that's that. Alright, so let me explain this example one more time. I don't think you get it. Let's see. What does A plus B star mean actually? A plus B star mean, in place of this, let's just break it down. What does A plus B mean? It means A or B, anything. And what does the star mean is, A or B can occur 0 times. A or B can occur 0 times. A or B can occur 1 time. A or B can occur 2 times, so on and so forth. So basically, informally, I can write it like this way. It is A plus B power 0, A plus B power 0, union A plus B power 1, union A plus B power 2, and so on and so forth. So this A plus B power 2 will be actually A plus B into A plus B. Okay, that's important. A plus B power 2 is not actually just evaluating this and then raising it to power. And this is what I call as an informal way. I mean, this is not a regular expression. Okay, this is not a regular expression. This is not a regular expression, but I just want to make a point clear. What does A plus B star mean? It's actually taking A plus B to power 0, taking a union with A plus B power 1, and taking a union with A plus B power 2, and taking a union with A plus B power 3. And when you evaluate this, this actually means A plus B into A plus B into A plus B into A plus B. Okay, cool. So basically this set of all string, this is actually basically set of all strings over AB. That's what it means. Cool. Okay. Okay, then yeah, we have discussed everything. Now let's just solve. I mean, we have just laid the foundation. There are 3 operators. Let me just revise. There are 3 operators. First is plus, or sometimes we represent a simple pipe plus, which actually represents union. Then we have concatenation, which represents ANDing. I mean concatenation, right? A followed by B. If I write A dot B, it means A followed by B. And we have the star operator. It means any number of times. It can be 0 times, 1 time, 2 times, so on. And there's one more. What if I write A plus? This A plus is actually equivalent to AA star. Okay, this is a regular expression, and it is equal to A into A star. Because plus is a valid operator, right? So how do you interpret it? A plus equals to A into A star. So this is nothing. This is actually same as Okay, let me write it only. It is actually A. So basically it is set of all strings over the alphabet which only contains A of length greater than equals to 1. Okay, so similarly A plus B power plus will be informally A plus B power 0 union A plus B into, okay, A plus B power 1 union A plus B square, and so on and so forth. Okay, this is the informal way. This is how you think about plus. Okay, 0 doesn't come, right? 0 doesn't come, sorry. So this is how informally you can think of it, like how plus works. It is actually set of all strings of one length, uh, set of all strings of one length, set of all strings of two length, and so on and so forth. Cool. Now let's solve some questions. Okay, now let's solve some questions. One question is set of strings. I mean, let's say I have an alphabet 0, 1, and I want to create a regular expression for language uh, in which every string ends with 3 consecutive ones. So my language, I want to create a regulation for a language which contains strings defined on this alphabet. Defined strings contain this alphabet, and they all should end with 3 consecutive ones. Okay, that is the L is a set of L is a set of strings over 0, 1 that end in 3 consecutive ones. So the language will be like this, right? 1, 1, 1, or 0, 1, 1, 1, or 0, 0, 1, 0, 1, 1, 1, so on and so forth. Okay, so how do you write it? How do you write a regular expression is? It's simple. What you do is, there can be anything first, any number of times 0 or 1, any number 0, 1, but at last there should be 3 ones. So what does this guy say is, any number of times, any number of times, any number of times, zeros and 1 can come, right? That's what it represents. Because if you put 0, if you instead of star, if you put 0, it means there will be epsilon. If you put 1, it means either it will be 0 or 1. If you put 2, it will be 0, 0 or 0, 1 or 1, 0 or 1, 1. So that's what, oh, I hope this is visible, right? Let me write it in a bigger way. So what I mean is, I want to create a regulation for language in which that contains set of strings that end with 3 consecutive ones. So how it can be written is, at first anything can come. At first anything can come. Any number of 0 and 1 can come, but it must end with 3 ones. Okay, for example, if we consider this string, anything can come in the first, any number of zeros and ones, but it should end with 3 ones. Okay, so yeah, that's that. Then we have on the same alphabet 0, 1, I want a language which contains set of strings that contains 1 at least one time. At least one time. Okay, at least one time 1 should be present. So what a little language, I mean, it will contain the simple string 1. It can contain 0, 1 or 1, 0 or 0, 0, 0, 1 or 0, 1, 1, 1, 0. I mean, it must contain 1 at least one time. That's what the idea is. So on the same grounds, you can write it like this way, right? 0, any number of zeros and 1, followed by at least 1, 1, followed by any number of zeros and ones. Okay, yeah, this is a perfectly valid regular expression. Any number of zeros and ones, right? Any numbers of zeros and ones, followed by 1, and any number of zeros and followed by any number of zeros. Okay, so this is what it is. When I simply write 0 plus 1 star, it actually means any number of times 0 and 1 can come. Why? Because if I put 0, it means it will be epsilon. If I put in instead of this power 1, it actually means 0 plus 1 power 1. What is it? What is it? It's actually either 0 or 1, right? When I write 2, it is actually 0 plus 1 into 0 plus 1, right? It is into 0 plus 1. It is actually 0, 0, 0, 1, 1, 0 or 1, 1. Cool. So that's a regular expression. And if you think a bit, this can be actually written more compact way. If you understand it, it's okay. Otherwise, this is also right regular expression. There is no doubt about it. It's like this. It can be also written like 0 star, any number of zeros, followed by 1, followed by any number of 0 and 1. It's same. I mean, if you think about it, they both are same. Any number of 0, followed by 1, and after that anything can come. They both are completely same. Okay. They both are completely same. Think about it. They both are completely same. Alright. So, one more question then. So one more. Set of strings which contains at most one time, at most one. Okay, so it should have only one time. So what is this language? Does it contain epsilon? Yeah, it contains epsilon. It contains 0. Yeah, it contains any number of zeros actually. 0, so on. And it can contain 0, 1. Yeah, cool. 0, 1, 0. Okay, makes sense. Or 0, 0, 1, so on and so forth, right? You got it. Then what will it be? Will it be something like this? 0 star, any number of zeros followed by 1, followed by any number of zeros? I mean, it represents a part of a language. I mean, it will represent all the strings which contains exactly 1 time 1, but it won't represent the set of strings which have 0 times 1. Okay, so for that, I actually have to add one more thing, plus 0 star. So what is this is? This is a set of string which contains number of ones equals to 1 time, and this actually represents a set of strings which contains number of ones 0 times. Okay, so and if I take a union of this is my language L, right? This plus is actually union, right? This plus actually represents union. So these are any number of zeros followed by 1 followed by number 0. This is actually the set of strings which contains 1 exactly 1 time, and 0 star actually represents the set of strings which contains 1 exactly 0 number of times. And that's what at most 1 means, right? 1 can come with a 0 time or 1 time. Cool. And in the last, when we have epsilon in our language, we just check if our regular expression is generating epsilon or not. It is generating epsilon, right? In place, if I just take 0 star here, you can see 0 star generates epsilon. Cool. Let's move on to another question. Okay. Let's say my alphabet is A, B, C, so on, up until Z. Cool. And I want a set of strings that contains L is set of string that contains the word main in it. I want set of strings that contains the word main in it. Okay, how do you do it? How do you do it? It's simple. I mean, if you think about it, it is a direct extension of that containing one thing. That contains one. Okay, I didn't explain that contains one, but it is simple. Let me show you how it works. Anything can come before main, a plus until z. Any number of alphabets before main, any number of these letters, any number of these letters before main, then main has to come, and then again any number of letters after that. Okay, I should write star here. Okay, the star actually remains whatever inside it is come any number of times. Okay, to make this notation more compact, let me do one thing. Let me take a variable letter equal to, you can do that. I mean, it's not common, but we can do that, which is equal to A plus B plus C plus so on up and until Z. So basically, this letter variable represents either A or B or C or D or so on up to Z. And what is my required regular expression is? Letter star, any number of times this letters. When I write star, you got it right now. If I put 0, it will be epsilon. It might happen that main is the first word. If I write 1, it can be single length strings over this alphabet. Okay, it can be single length string over this alphabet. Okay, so in general, if you are given x plus y plus z, they may not be single letters, they may not be single symbols. And if I put a star over, it is basically set of all strings over the alphabet x, y, z. And x, y, z need not be single symbols. They can be any complex symbols. Y might be, let's say, AB. But that's the point. If you have something like this x plus y plus z power, this star, it actually means set of all strings over the alphabet x, y, z. And x, y, z can be any complicated regular expression. Okay, fine. So where was I? Yeah, any number of letters. Okay, any number of letters first, then main, and then any number of letters after it. Right, this star represents any number of times this letter can come. Cool. Now Let's see one more on this model only. On the same ground, on the same alphabet, which contains all the English alphabets, or lowercase letters. I want a set of strings that have three consecutive x, three x that are consecutive. I want three consecutive x's. Okay, that's what I want. How can I do it? See, letter is a variable which contains all the which contains a plus b plus c, and that is, it can be any letter. That's that, and that is a letter variable. So the regular expression will look something like this: any number of letters in the beginning. So any number of times the letters a, b, c, or whatever, any number of letters, then x, 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 and then any number of letters after it, right? For example, if I have a string a b x, okay, sorry, a b x, 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 and y, z. So this is the letter star in the beginning, and this is the letter star after it, right? Any number of letters before and number of letters, and there is x, x, x. Okay. What if I say, instead of three consecutive x in the same question, containing 3x? Let's just before say containing 1x. Containing 1x. How do you do it? You again write this on the same ground, letter star, any number of letters before it, then x, and any number of letters after it. Okay, simple, not very complicated. Any number of letters before it, then x, and any letters after it. Now let's complicate a bit. Let me write it here only. Containing 3x. Okay, they are not consecutive. They can be anywhere. So it is interesting. See, any number of letters in the beginning, any number of letters in the beginning, any number of letters in the beginning, then 1x, then any number of letters after that x, then x, then any number of letters after it, then x, and then again any number of letters after it. Okay, so that's that. Let me write it. This moreover looks like a doctor's handwriting. Okay, and any number of letters after it. Cool. So this is a regular expression for it. Okay, any number of letters before x, then x, any number of letters after it, then x, and so on. Okay, cool. Now let's see some more questions. We are going to solve lots of questions, so it will be clear for sure. You just need to remember one thing: plus is for union, uh, plus is for union, concatenation is for concatenation, concatenation for concatenation, and star is a star you can represent it using, I mean, star, you can, in place of star you can put any number. You can be 0, 1, so on and so forth. And I already showed you the trick, right? It actually, if you, in a regular expression, you actually take the star. It is actually set of all the strings over the alphabet, set of all the alphabet. So I show you like this, right? X, Y, Z. If it's star, then it actually represents set of all strings of the alphabet X, Y, Z. That's what star. That's how I interpret the star. Okay, cool. The more formal way would be saying like that, right? The more formal way to represent star would be to take the language represented by a plus b power 0, take union with the language represented by a plus b, and take union by the language represented by a plus b into a plus b, and take union of language represented by a plus b into a plus b, a plus b, and so on and so forth. I'm lazy because since I'm lazy, I write this as a plus b square, but you got the point, right? This is a regular expression. This is not. Cool. So what I say is, this is a regular expression. This is not. But I'm lazy. That's why I want to represent the regular expression in this notation. It will be clear. Okay, we are going to solve lots of questions. Let's see a question here. Set of strings of length exactly 2. Let's define the alphabet. Uh, let's define it universally. Okay. Let's define it universally here. Let's say sigma is AB. Okay. Sigma is AB for now. I mean, if I don't say anything, it is AB only. And say a question: string length equals to 2. Mod W is string length. String length equal to, what is the language here? What is the language? Let's represent the language. The language is AA, BA, BB, and AB. Okay. So the simple regular expression would be to simply write it like this, right? AA plus BA plus BB plus AB. So it's a union of language represented by this regular expression, this and this. This is simple, but we can actually simplify it. We can actually simplify it. We can actually pull out A as common from left side, okay, from right side. So I can write like A plus B into A. This is important regular expression. When you pull out a symbol, you have to maintain the order. It's not like pulling out A from common. I can write here. No, you cannot do that. Okay, please don't do that. You will butcher the entire regular expression. So I will take B out from the right hand side. Okay, I guess this wasn't the best idea. Okay, I should have written better way. Let me write it. AA plus BA plus AB plus BP. Okay, so if I take AA common, it will be A plus B into A plus, if I take B common again, is A plus B into B. So it is actually equivalent to, if I again take A plus B common from the left hand side, it is A plus B into A plus B. I mean, I take time to derive this, but the idea is pretty simple. The idea behind this regular experiment is A or B followed by A or B. Okay, so this is the simplest thing. A or B followed by A or B, right? A or B followed by A or B. That is the idea behind this regular expression. This is the answer. This is the regular expression. I just wanted to show you how you can simplify regular expression. Cool. Let's see one more question on it. Of length at least 2, mod W greater than equals to 2. So this is at least 2. Okay, at least 2. So what do I want? Now I want strings of length at least 2. So A plus B, that is A or B followed by A or B. This represents the set of strings of length 2, and then A or B any number of times. So this actually represents mod W. This actually represents mod W 2 times. It represents mod W 2 times, and this will actually account for this at least 2. This is greater than equals to. This is actually this guy. Okay, this guy is actually mod W greater than equals to 0. Okay, so it is a length 2 string followed by 0 or more length strings. Okay, let me write it too. It's simple. It is a length 2 string, length 2 string followed by 0 or more length string, right? That's what will make a string length. That's what make a string length at least 2, right? So this will make sure the string length at least 2. String length is 2, and this guy will account for that at least part. So length 2 string followed by 0 or more length string. 0 or more length string. That's what this guy does, right? Cool. Let's see some more question on it. Length of strings of length at most 2. Okay. So mod W smaller than equals to 2. So this is the model of at most 2. So how do you write at most 2 then? This is actually finite language if you think about it. This was an infinite language of at least was an infinite language. This length 2 was a finite language too. So at most 2. So what is the language? Let me write the language. The language will be of length 0, it will be simply epsilon. Of length 1, it will be simply AB, or it will be length 2, right? AA, AB, BA and BB, right? So the simplest regular expression, the naive regular expression would be, you could just take a union of all this primitive regular expression, not primitive. Epsilon plus A plus B plus AA plus AB plus BA plus BB. I mean, that's the simplest kind of regular expression, but we can actually simplify it. You can actually take terms common and Uh, this will be actually equivalent to, you can do it, you can work out the simplification. It will be a plus b plus epsilon into a plus b plus epsilon. So the way it works is, I mean, if I want to prove you, this is the simplification of above expression is, see, we have to generate 0 length string, 1 length string, and 2 length string, right? Because this language contains the string length up and until 2. If you want to generate 0 length string, you take epsilon here, right? So this is what, uh, a or b or epsilon followed by a or b or epsilon, right? This is what this regular expression means, right? A or b or epsilon followed by a or b or epsilon. So if you want to generate 0 length string, just take epsilon both of them. If you want to generate 1 length string, uh, you take a here and epsilon here, b here and epsilon here, or epsilon here and a here, epsilon here and b here. It will generate 1 length string. If you want to generate 2 length string, you don't take epsilon in both of the places. You don't take it in both of the places, and then you can generate 2 length string. Fine. And on the same grounds, you can extend this question. You can extend this question to at most 3 too. If I want a string of length at most 3, it will be equal to a plus b plus epsilon into a plus b plus epsilon into a plus b plus into epsilon. So basically this is what, a or b or epsilon followed by a or b or epsilon followed by a or b or epsilon. That's what this regular expression means. If you want to generate 0 length string, take epsilon in every one of them. If you want to generate 2 length string, take epsilon in any one of these terms, and you'll get 2 length. If you want to generate 3 length string, don't take epsilon in any of these terms, you'll get 3 length string. Okay, cool. Okay, now let's see an interesting model. Set of strings of even length. So mod w is even. Okay, set of strings of even length. So I mean, how can you get an even length string? There is a observation here. If I have a 2 length string, if I have a 2 length string, and if I repeat this over and over, I'll get different length string, right? So how do you represent algebraically a 2 length string? It is a plus b power 2n, right? That's what it is. So, and n is greater than equals to 0. Algebraically, you represent it like this, right? A or b 0 time, then it will be the epsilon. It is also a string length even, right? It has 0 length. Yeah. By the way, epsilon has 0 length. I hope you know this. The length of epsilon is actually 0 because it doesn't contain any character. So what I'm saying is, if you want to get all the strings which are even, if you want to have a regular expression which represent all the strings that are even, what I need is, I need a regular expression for 2 length string, and I have to repeat it over and over. So what I can do is, if somehow I can get a regular expression for a plus b square, and I can repeat it over again and again, then I'll get all the strings of 0 length if n is 0, 1 length if n is 1, 2 length if n is 1, and if n is 2, I'll get all 4 length strings, and so on and so forth. So if somehow I can get the a plus b square, and I guess you know what is a plus b square. It is actually a plus b followed by a plus b. So this is the 2 length string, and I'll actually repeat this any number of times. Right? So this regular expression is our answer actually. This actually represents all the strings of even length. How? See, this is, let's call it x. What is it? It is actually set of 2 length string. Okay, it is set of 2 length string. This entire thing is what? It's x power 0, union x power 1, union x power 2, union so on, x power, there is no end here, right? You can go on and on. So what is x power 0? It is simply epsilon. What is x power 1? It is simply 2 length string, right? It is, or let me write one more step here. What is x power 1? It is actually a plus b into a plus b power 1, right? Or what is x square? It is actually a plus b into a plus b power 2. Now what is it? This is an informal way, but what is the respective regular expression? I already told you, right? It will be a plus b into a plus b into a plus b. Okay, I already told you how, this is an informal way of writing it, but the actual regulation will be something like this. So you got the point, right? You take the building block, there is a 2 length string and repeat it over and over again. If you put it 0, it will be a 0 length string. If you put 1, you will get 2 length string. If you put here 2, you will get 4 length string, and so on and so forth. Okay, similarly, on same grounds, what if string length is odd? What if string length is odd? Okay, cool. What you can do is you can generate all the even length strings, which is, let me write in different color. You can generate all the even length string, which is equal to a plus b into a plus b, that is a or b followed by a or b. So this forms a 2 length string, and I can repeat this any number of times. So this will actually form the even number of strings. Okay, sorry, this will represent the regular expression for set of strings uh, which contains the string length is even, right? In which the string length is even. So a plus b followed by a plus b and star. And you just append a or b one time, right? A or b one time, then it will contain odd number of characters, right? And moreover, you can actually append a plus b here too. So the another exactly right regular expression would be a plus b into a plus b into a plus b whole star. So the idea is you take the even length string and append one extra symbol, and then it will be an odd length string. And one more way to frame this question, the represent this question would be to actually write it like this. Write it like this. This is mod w congruent. Okay, mod w congruent 1 mod 2. It's same, right? What is it? It's actually, this is definition of odd length, right? By dividing with 2, if you get 1, that's what an odd length string represents. Cool. So they both are same. That's what I mean to say. Cool. Now, again, on the same grounds, we have another question. A set of strings that are such that string length is divisible by 3. Divisible by 3. What is the idea? You take the most smallest, what you can say, smallest regular expression that is divisible by 3, and you repeat it over and over. So what is the smallest regular expression that is divisible by 3? It will be a or b followed by a or b followed by a or b. So this is 3 length strings. Okay, this represents the 3 length string, and I repeat it over and over. So if I put 0, it will be 0 length. It will be 0 length string. If I put 1, it will be 3 length string. If I put 2, it will be 6 length string. So this is the building block. This represents the set of strings of 3 length, and I repeat it over and over, right? 0 time it will be represent epsilon, 1 time it will represent strings of length 3. If I write 2 here, it will be string of length 6, and so on and so forth. So this is the required regular expression. I take the most building block, which is divisible by 3, most what you can say fundamental regular expression that is divisible by 3, and I repeat it over and over. Cool. On the same grounds, we saw the above question. I can twist this question such that string length w congruent 2 mod 3. Okay, 2 mod 3. What is it? It's simple. I mean, can you think about it? What will it be? Can you think about it? What it will be? See, I need a string length of 3. I need a regular expression for string length divisible by 3. Okay, so oops, I don't know what happened there. So this represents the regular expression of all the strings divisible by 3. And after that, I can just append any 2 more symbols. Okay, see, this regular expression is for strings divisible by 3, and I can just append 2 more symbols. So which will make the string length such that if I divide by 3, I'll get 2. So what I mean is, if I, instead of star, if I put 0, I'll get epsilon. Fine, I get epsilon here. Then I append 2 more characters, maybe AB, so on. So in this case, the remainder will be 2, right? Similarly, if star is 1, the string length will be 3. Let's say it is ABA. Then I'll append 2 more characters, let's say AB. So it will be 5 length string, right? So eventually, I'm going to append 2 extra characters, which will make the remainder to be 2. Similarly, you can write it for a congruent 1 mod 3 also, if you just need to write 1 time A plus B. Moreover, it's not necessary to put A or B in the same way I put it. You can actually put this A here, or you can actually put them in any order you want. The one might be here or both might be here. The idea is they both needs to be present because they both were making the remainder 2. Cool. Set of strings in which no two number of ways are exactly 2. Okay. Question. Set of strings in no number of ways. Okay. Number of ways. Number of ways are exactly 2. Number of ways are exactly 2. So let me write the language. Okay. This won't be clear as simply. So this is a different kind of model. There can be 2 ways. So A will be present. There can be BA or there can be AABB, whatever. There can be BABA, so on and so forth. So A can be 2 and they need not be consecutive 2. Okay, they need not be consecutive. ABA is also a valid string of it. So how do you write it? Here's how we write it. Let me change a different color. This one, I guess. Okay, what was that? I don't know. Any number of B's, or let's just write it like this way. Any number of A's and B's. Not like this. Sorry for that. Okay. Any number of B's followed by A, followed by any number of B's, followed by A, followed by any number of B's. Right? Any number of B's followed by A, followed by A. Any number of B's, there can be 0 number of B's and then A and then any number of B's. This is, I guess this represents better. Any number of B's followed by A, then any number of B's followed by A, and there can be a B here, no worries. Okay. Okay, I guess I have represented A one more time here. I guess you all noticed it. Sorry for that. I guess my subconscious mind was working there. A contains exactly 2. Okay, so A can be present only 2 times. So any number B is followed by A, any number B is followed by A, any number B. Okay, so it's like this. There are 2 A's and you have to fill in the blank between all the gaps created by them. It is like that gap filling question. You can just say by putting 2 A's we form 3 blanks and those 3 blanks can be filled by any number of B's. If the input alphabet was actually A, B and C, these gaps would have been filled by B plus C, right? Any number of B plus C, any number of B plus C, right? So, I mean, you can extend this, right? You are getting what I'm saying. By putting 2 A's, I just have to put these gaps formed by putting these 2 A's. So, these gaps will be filled by, if there is only one alphabet left, or one symbol left, I'll fill it any number of that. If there are 2 alphabets, if there are, 2 symbols, 2 characters, I'll fill with them. Cool. Let's see one more model on this, which contains set of strings in which number of ways are at least 2. Sorry for that. So, alright, let's see language which contains set of all strings such that number of ways are at least 2. That is, they are greater than equals to 2. So, what will be this language then? And behind the scenes, I changed the colors of pen. Okay, so fun fact. It will be A. It should contain at least 2 A's. Okay, I mean there can be more than 2 A's. There is no doubt about it. B A A or A B A A B. I mean at this point, I mean you don't really need to write this language, but anyway, I just for sake of practice I've written it. See, first make sure 2 A's come, and after that any number of A's can come. So basically, any number of B's followed by A, followed by any number of B's, followed by A, followed by any number of A's or B's, right? So this part makes sure 2 A's comes. Okay. Let me get any number of B's until I see 2 A's. Okay, so that's what I mean. Okay, that's not the correct way. Let me get 2 A's first, and then I can get anything. Then I can get anything. Let me get 2 A's first, then I'll get anything. Okay, so this will ensure that I get at least 2 A's, and this will ensure that n number of A's can be possible after it. Okay, so that's what this is. This is the regular expression for it. Cool. Let's see. One more question, which is set of string having at most 2 A's. At most 2 A's. This is important. At most 2 A's means not mod W. number of A's, okay, number of A's less than equals to 2. That's what it means. So it should have at most 2 A's. So what does it mean? Either number of A's can be 0, either number of A's can be 1, or either number of A's can be 2. So what you can do is you can just write a regular expression for a 0 number of A's, regular expression for one number of A's, and write a regular expression for 2 number of A's. So here's how you write it. First, simply B star for 0 number of A's, there it will be any number of B's, or when A comes one time, what will it be? Number of B's followed by A followed by any number of B's. Or when two A's comes, or set of strings in which 2 is everything. B star followed by A followed by B star followed by A. This is same, right? This is a regular expression in which number of A's are 2. This is a regular expression for number of A's are 1. This is a regular expression number of A's are 0. And epsilon is covered. Yeah, epsilon is also covered. We can see that. And this language contains epsilon too. Cool. This is fine. I mean, this is completely fine regular expression. This is actually completely fine. Okay. This is our answer. There is no doubt about it. But can we do something better? This works, but we can simplify it. Turns out, see, there is no thing like minimal regular expression. But if you can simplify it, it's good, right? It looks, the more compact it is, the more good it looks. So if you can understand it, look at like this, look and try to understand it. Any number of B's followed by A or epsilon, followed by any number of B's, followed by A or epsilon, followed by any number of B's. If you think about, they both are same. How? See, if you want a zero number of A's, regular zero number of A's, take epsilon in both the places. Then you will simply get B star. B star followed by B star. B star. I mean, 3 B stars are actually B star only, right? So what I mean is, B star into B star into B star is actually B star only. Okay, cool. And so if you put epsilon in both of the places, you will get actually a set of all string which contains 0 number of A's. If you put either epsilon here or here, but not both, you will get actually a set of strings which contains a one time, right? So if you put epsilon here, you will get B star, A and B star. Okay, and I can, these two B star are same, you can combine them. These two B star are actually same, so it will be something like this. So you get this, right? And similarly, if you put epsilon here, it will be same thing. And if you want the set of strings which contains both A's, I mean exactly 2 A's, just don't put epsilon in both of them. Then you will get this expression. I guess it's simple to see, right? Cool. So if you can understand, it's fine. Otherwise, this is also right. Okay, but it's easy, right? Just try to think a bit. Cool. Let's see another example. This is gonna be easy. Number of A's are even. I mean, I don't know how you think about it, but these are more of like, involves little bit common sense. So they don't involve a lot of analysis. There will be some which will be hard, but most of them, they are very simple, right? They are easy to think about. Okay, fine. Let's not data from the topic. So I want a language which has a set of strings in which set of strings and number of A's are even. Okay, now same what we did in when we want a string length to be even. Create the building block, repeat it over and over again. Repeat it over and over again. So it will be, what is the building block? It contains actually 2 number of A's, and I can repeat it again and again. So what is the regular expression for in which number of A's are 2? B star, A, B star, A, B star. So this is actually the regular expression in which I have 2 A's, and I can repeat it over and over. But is this the answer? If you think about it, we are missing something. We are missing this part. This is some part. This covers some part of this language. We are missing only B's. Of course, epsilon is present here. We are missing where no A's is, where there are 0 number of A's. I mean, 0 number of A's are also even, right? So we are missing this part of the language which contains only B. So which you can simply append it like this. I mean, you can just simply use a union operator here. So this takes care when number of A's are 2, 4, 6, 8 and so on, and 0 also. I mean, but it doesn't completely take care of 0 also. It just takes care of epsilon, right? And this guy takes care of when number of A's are 0, right? Because in this case, it takes care of the language epsilon, B, P, B and so on. Right, so this was my building block. This was the regular expression in which I have two number of ways, and I repeated it over and over again. But there was one caveat. I actually forgot to include the strings which contain only b's. So I just take a union with the set of strings containing only b's. Now in this question, it turns out this can be simplified to b star, b a b star, a b star star. If you think about it, same. I mean, if you want any number of b's, just take it epsilon, you'll get any number of b's. If you want even number of a's greater, if you want number of a's 2, 4, 6, 8, you just take it as epsilon and repeat the same. I mean, in this case, it turns out to be equal, but it won't be equal in every number of every cases. But in this case, it turns out to be equal. Okay, fine. So you can think about it, how it panned out. Simple. Okay. Then we'll see set of strings starting with a. So I want a language starting with a. Oops. L is a language which contains set of strings starting with a. It's gonna be simple. I mean, you first need to have a and then anything after it. Right? It's simple. I mean, this was simple after saying a lot of this complicated. You have to start with a and then anything can come out, anything follow a. Okay. And similarly, let's see on the same grounds, ending with a. Ending with a. It's again very simple. I mean, anything before plus b star, and then it must end with a. So this is a regular expression. Then let's see one more, containing a. Okay, set of strings containing a. Oops. Okay, set of strings containing a. How will it look? A plus b, any number of a's and b's, then a, any number of a's and b's. Simple, right? Or there is one more, I mean, equivalent part of it. You wait till you see a, and after that you can have anything. Okay, so any number of b's and you wait until you see a, and then after that anything can come. Okay, cool. Now let's see one more interesting one. Starting and ending. Starting and ending. Starting and ending with different symbol. Starting and ending with different symbol. Okay, so there are only two symbols here, right? A and B. So either it can start with A, either it can start with A, end with B, or it can start with B or end with A. So it can either start with A and end with B, or it can start with B or end with A. How do you write a regular expression for it? See, first let's write a set of all strings in which it starts with A and ends with B, and yeah, let's write first that language, and we'll union it with set of actually set of with a language which contains set of strings that starts with A and ends with A. Okay, so first which I want to write a language in which contains set of all strings starting and ending with B. So A followed by A plus B, any number of A's and B, and it must end with B. And I'll union it, that is plus, with the language in which it contains set of strings starting with B and ends with A. Important question: should epsilon be present? See, you should ask yourself this question every time. Okay, with practice, I am not asking myself, as I have done in practice in most of the question. Just a second, there's some problem with my pen. Give me a minute. Okay, we are back. So, the question I was asking is, should epsilon be present here? So the thing is, as already told you in above questions, I didn't actually check if epsilon present or not, because with practice I know whatever regular expression I know is correct. But you should always check if epsilon present in the language or not. For example, if it contains A, then epsilon epsilon should not be present. That's why you can check that epsilon won't be present with regular expression, won't be represented. And if it ends with A, of course epsilon cannot be present, right? So you can check with all the example. If epsilon be present, it will be represented by the regular expression. My question is, does epsilon start and end with different symbol? I mean, epsilon doesn't contain any symbol. How will it start and end with same symbol only? So epsilon not present and it is not covered also. So by the way, this is our answer. Okay, so basically it is union of all strings, a union of two languages. One language is in which strings that start with and end with B, another language that start with B and end with A. Okay, fine, cool. Now let's see the same symbol model then. Starts and ends. This is gonna be interesting. 100% of you will commit mistakes here. I mean 99%. Starts and end with same symbol. You can pause the video and think yourself how are you gonna solve this. 99% are going to commit mistake here. Okay, and I will tell you it's not because of epsilon. Okay, so yeah, let me write it. Let me write the language here so I can show you what mistake can see. What is the language? It will be first. I mean, you can think of it like this way, right? The language can be union of two languages. First language will be it starts with A and ends with A, and for another language will be starts with B and ends with B. So what will be this language? This language will be ABA or some AAA and so on, and this language will be some BAB or BABB whatever. And one important that you might have missed is this. Single A is also a string which starts with and ends with A, and single B is also a string which starts with B and ends with B. Most of you might have missed this, I feel like. So these two are important. So let's just write the regular expression for any of these two languages. Then see, let me write first a set of all string which starts with and ends with A. So it will be A followed by any number of times A or B. Okay, let's in better way. A followed by any number of times A or B, and at last there should be A, or B followed by any number of times A or B, or the B. But if you see about it, they don't cover this A and B, so you have to write it explicitly. You have to explicitly union them. Okay, cool. So I mean, this language turned out was part of two. Okay, this language can be actually written like this: A plus B star, A, and simply A. This language can be again broken into two parts. Okay, B, A plus B star into B and simply B. Good. So we just took the union of every one of these languages. Okay, and once again, is epsilon needs to be present here? No. Why? Because epsilon doesn't contain any symbol. How will it start and end with same symbol? It doesn't contain any symbol. Okay, so that's important part. Now let's see some. We are on the verge of ending this video now, so let's see some few more examples, and then you will be on your own and you can practice questions. And moreover, you can send me questions too if you have any doubt. But yeah, let's see set of all strings such that number of b's congruent 1 mod 3. This is a sort of a revision question. We have already solved this question before. I mean, we actually solved the question like this, right? We actually solved a question like W congruent 1 mod 3. Right? It's same. It can be solved on the same grounds. Let me give a hint. What you do is you take the building block. You take the building block. That is, in this case, it will be the regular expression in which when it will contain number of b's divisible by 3. You can repeat it over and again. You can just append two b's. You can append, okay, 1b here, right? You can append 1b in the end. You can append 1b in the end so that the number of b's present will be actually, number of b's will actually, when divided by 3, will give remainder 1, right? Because the building block, repeating the building over and again will ensure that number of b's are divisible by 3, and just appending 1b in the end will ensure that we get the remainder 1 when divided by 3. Okay, if it was 2 mod 3, you would append 2 b's. This is hint only. Don't consider it an answer because you will definitely commit mistake if you are not aware enough. So let me just solve it. So let's just make the building block. I have to repeat the number of what I can say. I have to repeat 3 b's over and again. So what will the regular expression which contains 3 b's? It will be any number of a's followed by b followed by any number of a's followed by b followed by any number of a's followed by b followed by any number of a's. Okay, I have to repeat it over and again. So I'll write star here. So basically, this will contain all the strings in which there are b number of b's are multiple of 3. Now I just need to append one more b so that so that number of b's when divided by 3. So what I'm saying is I want number of b's to be 3n plus 1. That's what I want. If I append 1b, this will make sure the number of b's are 3n, and if I just append 1b, it will make sure uh, that wb congruent 1 mod 3. This is the answer. That's my question. No, it's not. Why? Because this is fine. Okay, this is fine. This represents some part of the language, but this regular expression is actually, you know, containing all the strings, which contains of course 3n plus 1 b's. This is a regular expression which contains all 3n plus 1 b's, but the caveat is all the strings end with b. If you see here, all the strings end with b, so there must be a star here and a star here, right? So this will make sure number b's are divisible by 3, and this will make sure I add 1b. Now I didn't say I have to add 1b at the last, right? That 1b can be present anywhere. Anyway, that's why I write a star and a star. And by a simple observation, you can actually cancel either this a star. Let me write it with different color. You can actually get rid of this a star or this a star. Any of these, okay? Don't get rid of both of them, otherwise there will be a problem. You can get rid of any of these. So the answer will still remain same. Okay, cool. And let's just, for sake of practice, solve one more question. WB congruent 2 mod 3. Okay, congruent 2 mod 3. What will it be? It will be, first, let's just write number of b's divisible by 3. Let's make b multiple of 3. It will be a star, b, a star, b, a star, b, a star, and we can repeat this another time. So this will make sure that number of b's are 3n, and now I have to write something here which will make sure the number of b's become 3n plus 1. I cannot simply write b because it will make sure the strings end with b, but I don't want that. So I'll write a star, b, a star. So this will add that extra 1. Okay, that 1b. And again, as I told, you can either get rid of this a or this a, but not both. You can get rid of any of these two. Cool. Okay, okay. There should be two b's, right? Okay. I guess my subconscious mind was working again. There should be two b's here, right? So the answer will be almost same. You will have to write 1b and a star again. Cool. Okay, so you have to append two b's in the end to get the remainder as 2. So this will make sure I get the extra 2. So here the aim is to get 3n plus 2 b's. Okay, the aim is to get 3n plus 2 b's. Okay, that was a little mistake on my side. Sorry for that. Okay, now we are going to see two very important questions according to semester point of view, and they are actually tricky. Okay, so pay your utmost attention. They will be a bit tough, but we'll conquer it. Okay, no worries. Alright, so that's all the most important questions. They are important in terms of for GATE as well, okay, or any other competitive exam. So let's the alphabet is still same AB. It is a set of strings in which no two A's come together. No two A's come together, or okay, no two A's come together, or another way to write is no A. So no A should be followed by A. Okay, no A should be followed by A. Okay, that means we cannot have consecutive A's. So let's write the language, right? I mean, it's not as simple and straightforward as what you've seen till now. So let's write the language. What is the language? Does it contain epsilon? It does contain epsilon, right? Because I mean, it doesn't contain any A. Then no two A's should be together. Okay, we cannot have something like this. This is not allowed. So any number of B's is also any number of B's can also come. So it can be 1 time B, 2 times, 3 times, so on, right? So this can come. Then we can have AB. Why not? There are no consecutive ways. I can repeat this AB, right? AB, AB, or AB, AB, so on. It might not write. I mean, it starts with A and ends with B here, but I can actually write append A in the end too, right? So I can also write this like ABA or ABABA or AB. Okay, these two are same. Sorry. So it can be AB, AB, ABA. Okay. So these are the strings that can be possible. Or I mean, it's not necessary the strings will start with A. They can start with B also. So it can be BA. Okay, it can be BA. A cannot come, so let's say BA again. One more BA. It can be also BA, 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 so on. Okay, and it's not the case that it must end with BA, BA. We can actually append a B and the end too, right? So we can also have BA, B or BA, 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 B or here BA, 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 B, and so on and so on. So I guess I have covered all the strings. There's one more string, right? I mean, any number of b's can be present after it. Any number of b's can be present after it. Any number of b's can be present after it. It's fine. I mean, that's assumed. So how do we approach this question then? How do we approach this question? So first of all, let's just find out what are the building blocks. What are the building? That is what parts are repeating, because I'm going to repeat it. Forget epsilon. I mean, we can tackle epsilon later. So what parts are repeating? First, this b is repeating. Okay, first this b is repeating. Okay, then this ab is repeating. If you see here, ab, I can append a after it. So ab is repeating. If you see, ab is repeating. Then this ba is also repeating. If you see, okay, this ba is repeating. So this ba is repeating. So we can append after ba a or b. That doesn't matter. Now what I mean here. So building blocks are, first is b. Okay, b can be repeated any number of times. Then there is AB. AB can be repeated any number of times. It's fine. BA can be also repeated a number of times. The fact is, I mean, so what I'm saying is, you can write something like this. You can write something like this. B can be repeated any number of times, right? So B can be repeated any number of times. So I'll write B plus, and B can be repeated a number of times. Or what can be repeated a number of times? AB can be repeated any number of times. Or BA, you might feel like, let's write that. See, B can be repeated a number of times, or AB can be repeated a number of times, or BA can be repeated a number of times. But this is wrong. Why? Because, see, if you write this, what will happen is, according to this, first you will write, let's say, BA, and then if you write AB, then it will give a string BAB. So it won't be a right string. So this is not the right answer. Okay, I'll keep it. I'll actually keep it as a side, so you know this is not a right answer, because you might feel this is a right answer, but it is not. So I'll keep it in the side here. Okay, you can observe it. That's not the right answer for it. Why I showed you? See, building blocks are B, AB, and BA, but I cannot write EB and BA at the same time. Why? Because if I do that, then I'll get A followed by A, and I don't want that. So we won't have that. Okay, cool. So let's see. Then what else can we do? So can I just write B plus? We want B, definitely we need B. Any number of B's are possible. It's better I just write AB, right? I just write AB or B, anything. So either this or B plus AB, not B plus AB, or B plus BA star. Okay, either this or this, they both will work. There's one problem here. I mean, this covers some part of the language. I mean, there's no clash here. It won't have any. I mean, this regular expression won't represent any string if there will be two consecutive ways. So it will represent some part of it. For example, if you observe all the strings here, they always end with B. If you think about it, one string might be possible is B. Another string might be possible is, let's say, ABB and ABB. So the problem here is, I mean, one thing is for sure, this doesn't contain any string which is not part of L, so that's good. But it always ends with B. The problem with this guy is it always ends with B. So what I need to do is, I need to add one more term, which is B plus AB and appending a at the end. Why? Because see, this thing, this thing will actually cover all the strings that starts with A, and end with B. Okay, it will cover all the string that starts with A and end with B, and it will also cover all the string that starts with B and end with B. So basically, it covers all the string that starts with B, irrespective of where it starts. But I also need one more group of strings. I need also one more group of strings, which actually starts with which actually ends with A also. Which actually ends with A also. So I don't know if we are getting this or not. Let me just explain it in some other way. See, these are all the strings we want to represent, right? These are all the strings we want to represent. These are all the strings we want to represent. So what I am saying is I can classify the string like this. It starts with and ends with. It starts with A, ends with A. It starts with A, ends with B. It starts with B, ends with A. It starts with B, ends with B. So what are the strings that starts with and ends with A? These are these strings, right? AB, ABA, right? AB, ABA, or this all class of strings. What are the strings that starts with A and ends with B? Oh, sorry. These are the set of strings that starts with and ends with B. AB, AB. Okay, and I never B's after that. That's not an issue. What are the strings that starts with B and ends with A? This is right. BA, BA, BA. Right? Or any number of B's and then BA, BA, BA. Fine. Then what are the strings that starts with B and ends with B? This BAB, BAB, or any number of B's in the middle and then again B. So what I'm trying to say is how can we do this? How can we do this? The way we do it is, see, I have to repeat any number of times B. And I can either repeat BA or AB. I cannot repeat both, otherwise I'll get two consecutive ways. So let's repeat AB. Let's repeat AB any number of times. So it will just contain some part of strings. It will contain all the strings that ends with B. Okay, it will contain only these strings. Okay, it will only actually comprise of strings that represent language comparison that ends with B. Okay, and starts with A. If you want to have a string that starts with A, just start with AB first. Okay, start with AB first. Take AB first. So I'm saying take AB, AB, and then take some B, so that you'll get all the strings starting with and end with B. And if you want a string to actually start with B, just start with B. Fine. But this is not enough. I actually want to cover these two, right? I actually want to cover these two classes too. That starts. This actually ends with A. Okay. So that's why I add one more term, which is B plus AB star into A. Now you can again simplify it. It will be B plus AB star. I'm taking it common from the left hand side. Okay, then it will be equal to A plus epsilon or epsilon plus A. I mean, you can change the order in in the union. Let me not change it to confuse you. Epsilon plus A. So what I'm saying is this is equal to A plus epsilon only. So this is our regular expression. So is this the only way? Not really. What you can do is, where should I write it? You got it, right? Let me write it below. So one another regular expression is, I have to repeat B, there's no doubt about it. But I can also repeat BA2, right? BA2. But the problem with this guy is, it contains all the string that starts with B. So it will only contain these two groups. It can end with A and B, of course. If you want to end with B, just take the last symbol as B. If you want to end with A, take the last symbol as BA. Take the last term as BA. Okay. So to account for that, it must start with A also. I'll add one more term, A plus BA into star. Okay. This will cover these two groups and this term will cover these two groups. Fine. So of course there will be some overlapping. There won't be any overlapping. There will be only one overlapping, and that might be of epsilon if it has to. Will it be? Will there be overlapping? That's my question. I don't think so. These two will have any overlaps. Why? Because it always starts with A and always starts with B. So these two are actually, what you can say, if this represents a language L1 and this represents L2, so L1 minus L2 will be phi. That's what I'm saying. Not or in other words, L1 intersection L2 is phi. That's what I'm saying. Why? Because this contains class of strings. This is actually a language which actually contains strings starting with B and this contains strings starting with A. Similarly here also, this contains set of strings ending with B and it contains set of strings ending with A. So they both are mutually exclusive groups. So we need these two terms for sure. Otherwise we won't get our complete language. Okay, I will not deal with epsilon. We'll see. We can see here, again we can see here epsilon is covered here. In the same sense, epsilon will be covered here. So let's simplify it. And for the simplifying, it will be, I have to take it from RHS, okay? So it will be A plus epsilon into B plus BA star. Okay, so I hope you got it. What we did is we divided the group. We found out the fundamental blocks that are repeating, and it were B, AB, and BA. But we found out that AB and BA cannot be taken together. Then our aim was to actually cover the class of strings that starts and ends with the following combinations. And we come up with these two solutions. One is this solution, and another one is this solution. Okay, cool. So yeah, let's I hope you got it right. So let's just solve another question, one last question. This is also gonna be interesting. This is gonna be comparatively easy. It is a set of strings in which there are no consecutive A's, so that is there are no two A's will be together. No two A's will be together. No two A's will be together, and no two B's will be together. Okay. By the way, if you still don't get the previous example, I actually request you to watch it again. I feel like I have covered every possible way I could have explained it. So please try to understand it. Watch it one or more times. You will definitely get it. Okay. So coming to this question, it has no two A's should be together and no two B should be together. So now B can also not be followed by B. Let's write the language first. Let's write the language first. Will epsilon be present? Yeah, epsilon will be present for sure. Now any number of A's or any number of B's cannot be present because A and B cannot be together. But in single A can be present or single B can be present. In previous case also single and single B can be present, and we can account for that. Okay, they will account for single and single B here. So no doubt in that. Okay, so single A, single B, and then AB will be present, right? AB, whatever that can be present. Then of course it's not necessary that it must end with B also. It can be ABA or ABA. You know where I'm going, right? I'm gonna write BABA. Write BA, BABA, BABA. And I'm not gonna write it. Just write ellipsis. Then it's not necessary that after BABA there can be B2. That's what I'm saying. There can be BAB. There can be BABAB. Fine. Any more languages left? I don't think so. So let's underline the fundamental building blocks. What are those? First is this AB. This AB is the fundamental building block. This AB. Okay, sorry. AB and B are the fundamental building blocks. But I guess that fundamental building block approach is a bit confusing. So let's just understand with the start and ends. See, what's my aim is? What is my aim is? I want strings that starts with A and ends with A. I want strings that starts with A, ends with B. I want strings that starts with B, ends with A. So this is the case. I want string that starts with B and ends with B. So let me give an example. Starts with A, ends with A. These are the strings. These are the required strings. Okay. Starts with A, ends with B. These are the strings. Okay. Starts with B, ends with A. These are the strings. Starts with B, ends with B. These are the strings. Okay. So it's for sure these all languages are gonna cover the entire language. You can cross check it again. These groups will actually cover every language possible. Basically, these groups, if I combine all the languages, if I write regular expression for languages, for respective languages, and if I actually take a union among them, they will actually cover the entire language. So they will be actually equal to the language I'll be required. Okay, fine. So let's see how can we do it then. So let me write regular expression all these languages Let me call this L1, call this language L2, call this language L3 and L4, and I know the answer is the regular expression for R1, R1 plus R2 plus R3 R4. That's my answer. But let's write the respective regular expression for all of these. Okay, let me take a different color here. Okay, let's just take a lighter color. Cool. So starts with A, ends with A. So what is the regular expression for those strings? They can be written as, if you think, any number of ABs followed by A, right? Any number of ABs, any number of ABs followed by A, right? Is it the only way I could have written it? There can be another way, right? You might argue, why not just write it like for A followed by any number of Bs? That's also valid, right? A followed by any number of Bs, yeah, that's fine. We can write it like that way. Cool. So there are two regular expressions for this language that start with and end with A for this L1. Now let's see the language which actually contains strings starting with A and ending with B. What are those languages? These are, right, A, B, A, B. So it will be A, B star, right? Any number of ABs. Can I write in a different way? You might say that, it's like this. A followed by B A star, A followed by B A star, and then B. Yeah, this works. The only difference is epsilon won't be present in this case. Epsilon won't be present there. This represents this L2, but epsilon won't be present. So, but it's fine. Let's just assume we don't need epsilon. We can account for epsilon later. So yeah, these two are equivalent. Let's assume that L2 doesn't get an epsilon. So these two are equivalent. Okay, they represent the same language. Okay, I mean, okay, I take my words back. These two are not equivalent. These two are not equivalent, but it's fine. We can use any of these. Okay, we don't care about epsilon. Either L2 contains epsilon or not, I don't care, but I can use any of these expression. That's what I meant. Cool. So what about the string starting with B and ending with A? Let's see. Where are those? This is that. So it can be written as B A star. Okay. It can be written as B A star, or one might say B A B star and A. See, these two are not exactly equivalent, but I don't really care about epsilon. Okay. L2 can be this or this, I don't care, but what my intention is, it should contain all the string. It should contain all the string that starts with B and ends with A. I don't care if epsilon present or not. I can account for epsilon later. So this both regular expression will work for L3, okay, because I don't care L3 contains epsilon or not. Okay, fine. Then L4 starts with B and ends with B. It's simple. It's this, right? So it can be either B followed by AB star, B followed by AB star, or one might say B star followed by B, B star followed by B. Cool. So how do I form L then? L is union of L1, L1, L2, L3, L4. So I should just take one expression for each L for each language, and if epsilon is not present, I'll account for it. Okay. So currently I don't care about if epsilon is present in any of these. So let's see. I mean, how should we combine them? Just take one expression in each. So let's just take all the expression which contains BA. So I'll take here for L1 I'll take this expression, for L2 I'll take this expression, for L3 I'll take this expression, and for L4 I'll take this expression. I want to actually combine all the terms which contain BA. Okay, so let's combine them. So it will be, let me write it, A into BA star plus A into BA star into B plus BA star plus BA star into B. So let's take B star common. Please don't mess up with the concatenation order. You make sure you maintain the order as much as possible. So how do you want to take B star as common? So let's go step by step. I don't want to take every one of them common into one because it will confuse you. So let's just take these two guys as common. Okay, how does it work? Let's see how does this work. So if I take B star as common, it will be A into, okay, give me a minute. Okay, so where was I? Let's just take the terms common and we can continue. Let me see. Hmm. So in these two terms, what is common? You can clearly see A, B, A star is common. And in these two terms, actually B, A star is common, right? I could have taken B, A star common too, but this is simple. So that's why I'm doing it. If with practice, you'll know why this is simple. Okay, so if I take A, B, A star common here, don't mess up the concatenation order I'm saying. I'm taking it from the left hand side. So it will be epsilon plus b. Yeah, in a plus you can actually mess up the order, there's no doubt, but in epsilon concatenation, AB is not equal to BA. You know that. But A plus B is equal to B plus A, that's fine. They are equal. There is no doubt about it. But yeah, that's just a general note. So basically concatenation is not commutative, but union operator is commutative. You can make a note of it somewhere. Alright, epsilon plus b, and from this side I am taking simply b star common from left hand side. So again it will be epsilon plus b or b plus epsilon, doesn't really matter because plus is commutative. And then what we can do is we can take epsilon plus b common from the right hand side. So it will be a b a. We can actually take here entire this common, right? We can actually it's very important to concentrate. There is utmost concentration. We can actually take the entire BA into epsilon plus B as common, right? So I can write it like this way: A plus epsilon into B star into epsilon plus B. Cool. So this is the answer. This is the answer, final answer. This is the final answer. I'll give you one shortcut how you can represent what just happened here. What just happened here? I mean, I'll give you a shortcut to this language. I mean, if it is asked in MCQ, there's a shortcut to this. See, what are we given? No two A's or no two B's can come together, right? So you can, I mean, it depends how you see it. According to me, it's a shortcut. So what is your language L is? How does your language look like? Your language should have BA, 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 BA because it cannot have two B's or two A's together. It can have BA, 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 so on, many BAs. And at first, there may be A or not. There cannot be B here because there's B. At first, there might be A or not. So this dot dot represents BA, BA. And at the end, there might be a B or not. Okay, so that's what this L represents. And the regular expression for this is simple. It's A plus epsilon into BA star into epsilon plus B. Similarly, you can view L. I'm not going to derive the second expression. You can actually derive the second expression taking AB, AB common on the same grounds. If I let me give you another example. Give you in context of that. This L can be thought of like many ABs. Okay, this L can be. Oops. This L can be thought of many ABs, so many ABs. Okay, not two A's together. It can be thought of many ABs. Okay, I mean it contains strings which contain any number of ABs, So this is AB. This order represents AB. And at first, there as there is a, there can be a B or not, and at last there can be a or not. There cannot be B. There can be A or not. So the another regular expression is actually B plus epsilon into AB star into A plus epsilon. Now you'll get the same answer if you just take the AB terms common here. You'll get the same answer. Okay, this is not something. Just try to understand it if this shortcut makes sense to you. So yeah, so that's all about regular expressions questions. So we'll end this video by discussing some of the identities of regular expression. I'm not going to waste your time by writing all the identities. Let me just fast forward and I'll write the identities for you and we'll continue from it. Alright, so these are some identities of the regular expression that we need to know to solve questions quickly. I'm not going to discuss the formal proofs, it's not required. I'm going to give you the intuitive understanding how does they work, and they won't be asked to. Okay, in a semester exam I don't think someone will ask you to prove this. There are better questions possible. Let's see. So first is phi plus r equals to r plus phi equals to r. So what is phi? Phi is a regular expression which represents empty language, and plus is union. So if you take a union with, let's say r here is, for sake of understanding, r is a. R is any regular expression, but let's say it's a. So R will be basically represent the language containing the string only A. Of course, if you take a union with empty set, you will get R only, right? I'll simply get here A only. Okay, so simple. If I take phi into R, that is I take concatenation of empty set with A, what do I get? I guess I'm saying it as a Cartesian product, but it's not. It's like dot product. Of course, it's similar to Cartesian product only. It just we multiply them. We don't write them as ordered pairs. So if I multiply an empty set with actually another set, it's dot product is actually empty set only. Okay, so that's the reason this is phi. Okay, the dot product of empty set with actually an any length set is actually phi only. That's just the set theory. And then we have epsilon into r. So what is epsilon? Epsilon is actually language containing only epsilon, right? And I have to concatenate it. R here is A, so language containing only string A. What will be the answer? It will be simply epsilon multiplied by A. I know how. I think I hope you know how to find dot product, right? You take every string in this set and multiply with every other string in the next set and write them. Okay. It's funny we are discussing in the end, but yeah. So it will be simply epsilon into A or R into epsilon. In that case, it will be A into epsilon. So what does it mean? It's nothing followed by A and it's A followed by nothing. Epsilon is nothing, right? So of course it's R. Of course it's R. I can actually replace the epsilon. They both will be same. Cool. Then this is interesting. It's epsilon star equals to. Okay. What is epsilon star, by the way? What does the star mean? I mean, we know the formal way is actually the language root epsilon bar 0, union language root epsilon bar 1, union epsilon language root epsilon 2. Okay. This is how we represent formally. What is this epsilon bar 0? It actually represents the language which contains only epsilon. Okay, I don't care what else, what will be here. Of course, here it will be simply epsilon, here it will be epsilon into epsilon. The language represented by this thing, okay. This is not a regular expression, but I just write it informally, you know that. So, this is the language represented by this guy. This is the meaning of star, right? You instead of star, you put anything, 0, 1, 2, and you just union all the language represented by the expressions. And we can see we are getting epsilon only, so it's epsilon. On the same grounds, we won't have just this term, right? We'll actually start with epsilon bar 1. It's fine, right? It still will be epsilon. We're not getting anything more than that. This is interesting. Again, phi star is actually epsilon. Okay, so here's how you think about it. Instead of star, you can put anything. So it's phi power 0 union phi power 1. I don't care. Rest all will actually always give empty language, but this phi power 0 will actually give a language containing only epsilon, right? So yeah, it's on the same grounds. Here it was epsilon power 0 was there. I got language of epsilon or anything. If there is something like a power 0, it represents a language epsilon. Here at 5 power 0, it also represents a language containing only epsilon. Cool. So that's that. Okay, let me erase this a bit. You can make a note of it if you want. One is going to ask you this. Okay, cool. Then we have this epsilon plus r into r star or r star into r plus epsilon equals to r star. How to interpret it? So what is r into r star? Then first let's discuss it. See, r is a, I already told you, and r star is a set of strings, any length strings greater than equals to 0. So it will be a power 0, that is epsilon. It will be a, it will be a square, it will be a cube, so on and so forth. If I take a dot product with it, I have to take this a and multiply with everyone, right? So what do I get? I'll get a into epsilon, which is a. I'll get a square, I'll get a cube, so on and so forth. So what is this? If you think about it, it's actually set of all strings greater than equals to 1. And if I simply add epsilon, that is I take a union with epsilon, this is actually r plus. This is actually r plus, right? It is actually set of all strings set of all strings greater than equals to 1. But if I just simply take a union with epsilon, I'll get r star again, right? So that's what it is. This is r plus actually. This is r plus. And if I actually in r plus I take epsilon 2, I'll again get r star back, right? So that's just that's the, I guess, proof. So this is actually r plus. That's what I'm saying. In r plus, epsilon is not present, right? Because it actually starts the string length with 1. But if I just add that epsilon, of course I'll get a string length 0, which is actually epsilon itself. Now this, okay. Mhm. Let's start. So this is a plus b star. So what is a plus b star? You know what is a plus b star. Instead of star, you can put 0, 1, 2, or anything. But intuitively, we know that it is any number of a's and b's. Right? It's any number of a's and b's. That's what a plus b star is. So the idea is you can actually, what I can say, uh, you can actually take star in both a and b, at both a and b, or simply b. You will get the same thing. And it's easy to see. Let me show you how. What is this expression? What is this expression? This expression says any number of a star and b star. It's fine, right? Any number of a star, b star. It, I mean, a star. You can any number of times any number of a star, b star. Okay, so it's same as that. Any number of a's and b's is same as any number of a star, b star. Right? Instead of star, you take whatever power you need because star represents any power, right? I guess it makes sense, right? And so on the same grounds, it is any number of a star and b. It's fine. You can take any power for a star you want. It will be same as this only, right? On the same grounds, any number of a and b star. You can take any power for b star and you'll get the same thing as it is. Okay, you'll get the same thing and you will get more than that. That's what I'm saying. Okay, you won't get more than that. This is kind of interesting. See, a star into b star. See, there's no there's no plus here. I've concatenated it. So this is what? This is any number of times a star b star. Any number of times a star b star. That's what this star indicates. Any number of times a star b star. See, what was this? It was any number of a's and b's. Any number of a's and b's. Whenever I want a of out of this a star b star, I take b star as 0. That is, I'll take epsilon instead of b star. And if I want b, I'll take a star as 0. So this kind of mimics any number of a's and b's, right? Any number of a's and b's. Because whenever I need a b, I'll cross off this a star. That is, take epsilon in place of it. Whenever I write a star, or whenever I need any number, whenever I need a, I'll cross off this b star. Right? On the same grounds, this is a star b a star. So this is actually a star into any number of times b a star. Okay. So the idea will be, if you want to start with a, don't take this as 0. Don't take it at epsilon. If you want to start with b, take this at epsilon. Right. On the same grounds, this is also true. This is what? B star into a b star, any number of times a b star. See, if you want to start with a, take this as epsilon. Take this as epsilon. And if you want to start with b, don't take it epsilon. Simple, right? So they all represent the same thing. Okay. If you don't remember proof, it's fine, but remember the identities because they come handy. And these are the most simplest one. R plus union R star is actually R star. It's obvious. R plus is what? It's actually a square, a cube, so on. Union a power 0, which is actually epsilon, a square, so on and so forth. So by the way, this a square is a into a. Okay. If you take a union of it, I don't know if you observe this or not. R plus is actually a subset of R star. R plus is actually a subset of. It's not just subset. It's actually a proper subset. R plus will never be equal to R star. As R plus is a subset of R star, of course, because R star contains strings of every possible length starting from 0. R plus contains strings of every possible length starting from 1. So as R plus is a subset of R star, I'll write it. Of course, if I this is a simple set theory. If A is a subset of B, A union B will be equal to B only, and A intersection B will be A only, right? So these two properties come from that. Good. Okay. Then there is R star into R plus. Okay, what is R star? It's epsilon A a square so on concatenation with a square a cube so on, and concatenation I hope you know. I take epsilon and multiply with everyone, I take k and multiply with everyone, and I write the answer. See, everything boils down to whether epsilon is present or not, because rest every string will be present definitely. Okay, how uh, how rest everything string will be present? If I just take this epsilon here and multiply with every other thing, all the strings greater than equals to one length will be present only. Okay, but will epsilon be present? I don't think so, right? Because there's no way I'm getting epsilon here, because if I even if I take the smallest possible string epsilon here and multiply, there is no epsilon here, so we won't get any epsilon here. So this is actually r plus 1, right? Because I'll get all the possible strings greater than equals to 1, length with length greater than equals to 1. Okay, and this is, yeah, now these three are interesting. See, r star star. What is this star? Remember this thing. Star is actually universal in itself. It already contains strings of all possible length. You take, I mean, how many other stars you want to take. What is the star? The star means power 0, 1, 2, so on and so forth. Even if I just take this power 1, I'll get every possible string. Right? So what I'm saying is this r star is actually equal to r power 0 union r power 1 union. Okay, it's not like this. What is this? If I, instead of this star, if I put 0, I get r star power 0 union r star power 1 and so on. See, I don't care what lies here. I don't care what lies here. Only this guy is enough to give me all the possible strings. This guy is enough to give me all the possible strings. So it will be r star only. Okay, cool. Even if you multiply r star with r star, you are not going to get any more strings. R star in itself contains every possible length string. Okay. On the same grounds, this is r plus. This is r plus. It will be r0. Okay, not like this. It will be r plus power 0 union r plus power 1. This will be set of all strings greater than equals to 1, and this will be epsilon. So we get the epsilon and set of all strings greater than equals to 1. This will be r star. So what the consensus I'm trying to make here is I'm trying to prove a point here. No matter, okay, let me just erase it first, then I'll say. See, you are given r, and no matter how many power, how many pluses are there, even if there is one star, it's enough to prove the point. Then this will be equal to r star only. Okay, so this one star is actually enough to prove the point that an answer will be r star only, because everything boils down to whether epsilon is present or not. And if there is a star, I can take everything as 0 and get epsilon, and if I put 1, of course I'm gonna get every other strings. Cool. So can you answer this then? See, doesn't really matter whatever is there. I just know there is one star here, so it will be r star. This entire thing will be r star, and r star into r plus. What is it? We just saw it, right? It is actually r plus. So that's that. So that wraps up regular expressions. I hope you enjoyed it. Please do send me questions if you have any on this topic. I'd love to solve them. Thank you.